Well, we need to find a rule in a table to see if it's a directly proportional relationship. Now, I want you to remember, honestly and truly, when we use the term directly proportional relationship, in your mind, you need to be thinking makes a line. Okay? Now, this is not like the easy proportions that you would see in sixth grade. It's not like something you would see at the beginning, like the last chapter of rates, ratios, and proportions, where it's just like an afterthought almost. This is where it's a relatively hard thing to wrap your mind around. And the only thing that I can get to is this. We need to be able to say I can find the pattern, and if I can find a pattern and this pattern holds true for the whole table, and when I go graph it, it makes a line, then I would know it's directly proportional. If I can't find that pattern, then I'm just going to say it's not proportional. And there's a lot of other tricks that we can use, and your parents are probably sitting down saying, why don't we just, take like -1 over -3 and have it equal to 0, 0, and see if we can cross multiply. Well, 0 times -1 is 0, and 0 times -3 is 0, and that works. And then why don't we just check 0 over 0 for this being the second ratio, and 1 and 3. Well, it's the same thing, and 2 and 6, and 3 and 9, and that works for this one. Don't get me wrong, it works for this one, but we're going to be coming up with some other relationships shown in tables where that does not work, and it makes me scratch my head why we have that in seventh grade, but I've got a feeling it's going to pop up, and we can get around it with using this rule of, okay, let's find a rule or a pattern that's going to help us explain this table. If x goes up, does y go up or down a certain amount? Okay, how much did this go up by? Plus 1. So -1 to 0 went up by 1. How much did this go up by, or did it go down? -3 to 0, that went up by 3. So let's go see if this rule works. From 0 to +1, it went up by 1. And 0 to 3, it went up by 3. 1 to 2, it went up by 1. And 3 to 6, it went up by 3 again. And then right here, we see that it maintained the same movement. And so as a result, if we go and we graph these 5 points right here, you see right here that we have -1, 3, or excuse me, -1, -3 plotted right here. We have 0, 0 plotted here. We have 1, 3 here, 2, 6, and 3, 9, and it makes a perfectly straight line. And what I'm saying is it has to be a straight line because the relationship of how it grew every single time the x went up by 1, the y increased by 3, makes it directly proportional. Now, how can these side questions help? I would say take a look to see if you can find a pattern. If x goes up by a certain amount, does y go up the same amount each time? It doesn't have to equal it. Like this y is going up by 3 and this was 1, but each time x went up by 1, is the y changing the same amount each time? Over here it went up by 3 each time. Over here on the x, it went up by 1 each time. And this is not as big of a deal. It's just we're looking at this proportion relationship here. So now let's go through and look at this here too. Um, let's do 6 of these together, and we'll determine if it makes a proportional relationship, and then we'll graph them to see if it makes a straight line. Now, um, if x goes up a certain amount, does y go up the same amount? Well, if you notice here, the x went up by 2, and over here the y went up by 10. We go up by 2 again, and here it goes up by 10. So let's make a ratio. Um, x over y. Our x went up by 2, and our y went up by 10. So could we shrink that down and say, well, yeah, it would go for every increase of 1, it would go up by 5. If this was 2, and we put 2 into this, what's 8 plus 5? 13? So 8 plus 5 is 13, plus 5 is 18. Okay. If I add 1 to 3, that puts us at 4. If I add 5 to 18, that puts us at 23. If I add 1 to 4, it puts us at 5. And if I add 5 to 23, it puts us to 28. So it looks like that this rule is probably going to be holding up, but then what they do is they throw us a little bit more of a curveball. As we're looking through here, suddenly we jump up by 4. Whoa. Okay. And now we're like, well, we jumped up by 20. Well, 4 over 20, x over y, does that simplify down to 1/5? Yes, it does. So we're still okay. This time we jumped up by 1. And if you notice, oh, this time it jumped up 5. 1 over 5? Yeah. What about this one? This one jumped up by 10. This one jumped up by 50. What's 10 over 50? Yes, so basically it's a way that you can find the pattern of change between the x's and y's, and if you can basically put your x over your y's and lock it down to where you get the same ratio every time, that's going to work. So that's probably my number one helpful hint right here, because it handles even the easy ones, but it does the hard ones too. Other times you might be able to say, hey, if I multiply x by something, I get this, or I can add or subtract or divide. That's what these other questions are down here, but this is the one that is the most helpful. So this is a directly proportional relationship, okay? So it's directly proportional. Let's go on. Oh, actually, hang on. I'm going to go and graph all of these points in for us, and then we'll see that it does make a straight line, because remember, directly proportional means it's going to be shown as a straight line on a graph. So here I've put in the data. I'm about to update it. There we go. You'll see 1/8 was here, 3/18's here, 5/28. Here we've got 9/48, 10/53, and then suddenly here's 20, 103. And it all makes a perfectly straight line. So when you're asking yourself, is this a directly proportional relationship? Does it make a straight line? Yes, but when you don't have graph paper, you're breaking it down and seeing if this pattern relates into where the y value is changing the same amount every time when we know how much the x value is changing. So let's go on to number 2, and let's take a look at this one. First thing I would say is this, let's just go ahead and use our first strategy. This one up by 2, and this one up by 2. Let's go ahead and take a look over here. This goes down by 2. Hey, that's okay. Now, when this goes up by 2, this should go down by 2 again. Whoa, this something went up to 8. Do you see we have an issue here? If it's directly proportional, when the x changes the same amount each time, we're going to see the same change in the same direction each time. If it goes up by 2, it should go down by 2 the second time also. So here it is going up by 2 again. The y value, or in this case the p value, actually jumped by 8. So this is not proportional. And now let's go put this on the graph so we can see it. So here's what we had on the table, and right here is all of our data plotted in. Do you see how it is all jagged and makes no sense? And that's what I'm trying to tell you, is that it did not keep to a pattern or anything else. So as a result, this is not proportional. And over here, okay, this goes up by 2 again, but suddenly this drops by 12. So it doesn't make any sense. This goes up by 2 again, and now we get 8. And this goes up by 2 again for the m, and suddenly we drop by 12. There's no rhyme or reason. There's not a movement that's predictable, and so we would say it is not proportional. Here's number 3. Let's see here. This one's going to be a little bit more tricky, but it's good for us to learn on. 1 goes up to 5, so that's a +4. And -2 actually goes down to -8. That means that we lost 8 spots. So let's put this into a ratio. 4 over -8 would simplify down to 1 over -2. So that means when V went up by 4, the W went down by 8. So every increase in 1 in V, since that's the top number, would bring about a decrease of 2 in the W. So now, if this goes up by 2, we'll see what happens here. This dropped it by 4. So does 2, -4 simplify down to 1 over -2? Yes. So okay, we're doing okay. Now we're going to go up by 2 on the V values, and the W values are, it's the same thing again. For an increase in 2 in V, we have a decrease in the W, so we get the same thing. And plus 2 minus 4 plus 2 minus 4. So yes, this is directly proportional. So let's pause it and go plot them. And look at this. Here's the X value running up here. We plot all of these points down. It runs into quadrant 4, and it makes a perfectly straight line. So yes, it is directly proportional, but we knew that because the change always comes back to the same ratio. Okay, let's go and do this one together. This one I like easier because every single increase in X on this table is actually up by 1. So here we go, plus 1, plus 1, plus 1. 2 to 3 is plus 1, and 3 to 4 is plus 1. Now let's see if we can find the same change. 2 drops down to negative 7. Well, that's a loss of negative 7. So 1 was our X value that went up, and our Y was a loss of 7. So now this goes up by 1. Let me get a little bit of red here. Okay. So now we're going to move from negative 5 to 8. Wow, that's an increase of 13, but we still have, this increase of 1 right here. So it's 1 over 13. Is 1 over 13 the same as 1 over negative 7? No. So it's not proportional. Okay. If we go and graph it, this will be the last one that I graph. If we go and graph it, it shows absolutely a jagged graphing of all of these points. If you're interested in actually using this tool that I am, if you go to showdor.org, enter activate / activities graph it, you can actually use this. You just type in your data points, you can put a comma to separate them, and then you just say plot update and it changes it. So for example, if you needed to plot 2 5, 2 comma 5, well, there's 2 5. You see here's 2 and there's 5. Then if you needed to see if it connects to 1 6, you hit enter and it didn't do anything, but you hit plot update and suddenly there's 1 6. And then if you go, well, 0 7, does that work? See, I actually put a space in there. It's not too sensitive to it. You see it's still a straight line. And that's because X kept decreasing by 1, but my Y value went up by 1. So it has this pattern, it's proportionate, and it can show you if it's a straight line or if it's a lot of issues on there. Now, let's go through and do the last two real quick. Let's see. 1 went to 3, so that was an increase of 2. So my F value went up by 2. My G value suddenly dropped by 6. So that was a loss of 6. That will simplify down to a 1 over negative 3. That's the magic ratio we're trying to see if we see again. So this time we went up by 2. This time, though, we actually had an increase of 19. Well, 2 over 19 does not get us down to 1 over negative 3. Sorry, this is not proportional. Six. Here we go. If you notice, the X values are jumping up by 2 every time, so 0 goes to 2. And now this one jumped up by 3. So my J value, when that increases by 2, I take a look at my K value and I go, you know what, my K value jumped up by 3. Let's go see, since that's as easy as I can simplify it, let's go see if it happens again. Up by 2 with J, well, this one jumped up by 3. Okay, let's check to make sure it happens every single time. Up by 2, up by 3. 6 to 8 was an increase of 2 for my J value. My K jumps up by 3, so it's happening. And in fact, it followed through for the entire table. So this is a directly proportional relationship shown in this table. And if we want to pull in our last lesson, for every as J was increasing, as your first variable is increasing, the second one was increasing too, so it's actually a positive relationship. They're both getting bigger. That means when you go to graph it, it should be going up to the right in some manner. That's really all I have. You've got some questions on there tonight. If you have trouble with this homework, I want you to just come in and say, I had a lot of trouble with it, and we will tackle it more as a class. We had so many notes, so it slowed us down, that I just want to make sure that we can do it together, that we can reason, that we can work with our groups and get better at it. And I think you will by tomorrow. So good luck. If not, you watch the video. This will help, and we'll clear things up tomorrow.